Welcome to this eLearn security video training lesson on Metasploit. In this video, we are going to learn how to use and configure Metasploit in order to find vulnerable target machines and then exploit them in order to get an interactive shell on them. Metasploit is a security tool for developing and executing exploits, attack vectors, automate routines, tasks, and much more. Metasploit greatly helps penetration testers during all phases of a penetration test, from the information gathering tasks to the exploitation and post-exploitation phases. Metasploit comes with 3 different versions, as we can see here in the download page. The Metasploit Pro version is fully functional and has no feature limitations. The Metasploit Community Edition has some limitations, but is good enough if we want to start using the tool, or if we want to conduct penetration tests on small networks. The last version is the Metasploit Framework. This version is essentially used by developers or advanced users, and it's command line based. If you are using a Kali Linux machine, you do not need to download Metasploit since it's already installed on the system. Almost every week, the tool is updated with new features, exploits, and so on, so it's a good practice to always keep it updated on your system. To do this, we just have to click on Application, Kali Linux, Exploitation Tools, Metasploit, and select Update Metasploit. A new terminal window will appear and the update process will start. As we can see in the output, we already have the tool up to date, so we are good to go. Note that we can also update Metasploit directly from the terminal by running the msf update command. Here indeed, we can see we have the same results obtained right above. Before running Metasploit, we need to start a few services. These are services that Metasploit will use to load resources and data needed for the tool to work properly. The first service we want to run is PostGRE-SQL, which is a DMBS that Metasploit uses to store data and information. It is also used by the framework to perform faster searches in the database. We can simply start it by running the following command: service PostGRE-SQL start. Once the database service is running, we need to start the Metasploit service too. This is as simple as running the command service Metasploit start. Once the command completes, we are finally ready to run Metasploit by typing msf console. Note that this task may take a while since it has to load many modules. We will know that it is finished once the prompt returns. Here we can see a small banner and some information about the tool, such as the current version installed on our system, the number of exploits available, as well as other modules such as auxiliary post, payloads, and so on. We will see later on what these modules are. As we can see, our prompt is changed and the string msf appears. This means Metasploit loaded successfully, and we are ready to start using it. The first command we want to run is help. This will prompt a list of available commands. As we can see, there are 2 main categories: core commands and database commands. The core commands, as the name suggests, are the most important and used commands of the tool. They allow us to configure exploit, modules, interact with shells, sessions, and much more. The database commands are mainly used to interact with the database. If you recall, we have started the PostGRE-SQL service so that Metasploit can connect to the database and store information while we perform our tasks. For example, if we use scanner modules to find new hosts on the network, they will be automatically added into the database. For now, let's start by using one of the most fundamental commands, search. As usual, we can display the correct syntax to use by running search-h. Here, we can see that we can configure our search pattern with specific keywords. These keywords will help us filter the search for specific modules. Moreover, at the end of the output, we can see an example of the command and how to use these keywords. Since we are at the very beginning, we will not restrict our searchers with any of the keywords listed here. Instead, we will run a search in the whole framework. Right now, we need to get an idea of our target network. We do not know anything about it. Hence, we don't even know if there are any live hosts. Since we are attached on the same network of our tests, one of the most basic scans to find live hosts is an ARP scan. This should reveal a number of hosts available in our network. As we already said, Metasploit offers many features and functionalities, Scanning networks is one of these. As we will see in a moment, we have the ability to scan the target network directly from the MSF console. To do this, let's use the search command to verify if there is any module that may help us run an ARP scan. So, let's type search ARP and press enter. We can see we have different modules that match our search query. Here indeed, there is a module named ARP_sweep that seems to fit our needs. In the description, we can see that it executes an ARP sweep on the local network. So how do we use this module? It's very simple. We just need to copy the path of the module and then run the command use followed by the module. As we can see, the prompt changes and informs us that we are within the module ARP_sweep. Great. Now we need to configure the module in order to specify which network to scan. In order to see the available options for a module, let's type show options. Here, Metasploit prints out all of the options and parameters that we can set for the specific module. Note that some of these are required, while some others are optional. For example, we have to set the parameter rhosts, which is required and is used to define the target address range we want to scan. So let's do it by running the following command: set rhosts 192.168.102.0/24. With this command, we are saying we want to see the variable named rhosts with the following value, which in our case is the network range we are attached to. So let's run it, then execute the show options command once again. As we can see, the value for the variable rhosts has been set. Right now, we have all the required parameters set, so we can run the module. To do this, we can simply type run and press enter. The module starts and prints out some IP addresses. These are all the live hosts found in our network. Great. Now we have a list of possible targets for our tests. Note that our IP address is not listed in the output. Indeed, if we run the ifconfig command, we can see that even if we are in the same network, our IP address is not there. The next step is to get a bit more information about the machine found in the previous step. For example, we may want to run a port scan and verify what ports are open or closed. So let's use the search command once again and search for port scan. As we can see, there are a few modules that we can use. For our tests, a TCP port scan is what we need. So in the same way we did before, let's select the following module by running the use command. Before running it, let's see what options we have to configure. Once again, we have to set the target host's IP address. This time, instead of scanning the whole range of IP addresses, let's run the module against a specific host. For example, let's target the machine with address 192.168.102.128. Moreover, let's set the ports range from 1 to 500 with the following command, and then check the module configuration once again. We are now ready to go. Let's run the module. As we can see in the output, the module starts probing the machine, and here we have a list of open ports. So far, we know that the target machine has few open ports, but this is not enough to run any attack against the machine. Although the Metasploit port scanner works pretty well, we know there is a tool which is better suited for this task. We are talking of Nmap. Nmap will help us identify the target machine OS, services running on open ports, and so on. So let's use it in order to get more detailed information about the machine. Note that we do not need to run it in another terminal. We can run it directly from the MSF console. So let's run a full scan against the target machine with the following command. You should already know that the -A option runs all the scans, such as OS detection, version detection, scripts, and so on. Let's wait a few seconds until it finishes and then inspect the results. As we can see in the output, the target machine has the following open ports and it's a Windows XP. Here, we can see some very useful information about the SMB service, such as the computer name, the workgroup, and so on. Since this is one of the most targeted services on Windows machines, we can check and see if this is somehow vulnerable. Instead of running a vulnerability scan tool such as Nessus, we can use the power of the Nmap scripts. Nmap indeed offers a very specific script that checks if the SMB service on the target machine is vulnerable. So let's configure the nmap command and see what we get. As usual, let's write nmap, followed by the script we want to run against the machine, which in our case is smb-check-vulns.nse, and then add the script arguments unsafe equals 1. Once again, this command verifies if the SMB service of the target machine is vulnerable against well-known vulnerabilities. Great! As we can see from the output, it seems that the machine is vulnerable to this specific vulnerability, MS08-067. Now that we know enough information about the machine, we can try to exploit this vulnerability in order to gain access on the remote system. As usual, let's use the search command in Metasploit and see if there is any module related to the vulnerability just found. So let's type search MS08-067 and press enter. As we can see, the search returns one result. From the module path, we can see that this is an exploit, which means we should be able to gain an interactive shell on the system. So let's select the module with the use command, and then show the available options. As we can see, right now we just have to set the rhost parameter with the IP address of the target machine. So let's run set rhost 192.168.102.128 and press enter. You already know that every exploit has a payload. That is the code that is going to be executed on the remote machine once the vulnerability is triggered. If we do not set any specific payload, Metasploit automatically sets it for us. Of course, we may want to use a different payload with different configurations, so let's see how to configure it. In order to list all of the available payloads for this module, we can run the show payloads command. As we can see, there are a lot of payloads we can use for this specific module. In this video, we are going to use meter-preter reverse TCP payload. If the exploit works, this specific payload will start a reverse connection to our machine and spawn a meter-preter session that we can use to interact with the remote machine. Let's then copy the string and use the set command to configure the payload. If we now run show options, we can see a new section for the payload options and parameters. The lhost parameter is the local host. In other words, the IP address of the machine of the attacker. This is the address that the payload will use to start the reverse connection. As you can imagine, the L port is the local port on which the payload will try the connection. Now we have everything set, we can run the exploit. To do this, let's type exploit and press enter. From the output, we can see that Metasploit starts a handler on our local machine. The handler will simply listen for incoming connections from the target machine. Remember that we have set a reverse TCP payload, which means that the victim starts the connection back to the attacker. Once the handler is set, the exploit tries to detect which operating system the victim is running and, as we can see, it detects a Windows XP SP3. Then it tries to trigger the vulnerability and send the payload to execute. The last line tells us that a new meter-preter session on the remote machine has been established. This means that exploit worked, and indeed, our prompt is changed. The meter-preter session is an interactive shell on the remote machine, but unlike common shells, it allows us to run pre-configured scripts and modules that help us to escalate privileges, gather information, upload or download files, and much more. Let's prove that we are on the target machine. First, we can check the IP address of the machine with the ifconfig command and see if it is the same as our target. As we can see, the interface 2 of the exploited machine has the IP address we used for our attack. So, now we are sure that we are interacting with a victim. Indeed, if we run the sysinfo command, we can see that the machine name is the one found previously and that it is a Windows XP SP3. Great! We have successfully exploited it. And this concludes this video lesson on Metasploit basic usage. Thanks very much for joining us.